In the last few videos, we learned that the configuration of electrons in an atom aren't in kind of a simple, classical, Newtonian orbit configuration, and that's the Bohr model of the electron. And I'll just keep reviewing it, just because I think it's an important point. If that's the nucleus, remember, it's just a tiny, tiny, tiny dot if you think about the entire volume of the actual atom. And instead of the electron being in kind of orbits around it, which would be how a planet orbits the sun. So instead of being in orbits around it, it's described by orbitals, which are these probability density functions. So an orbital, let's say that's the nucleus, it would describe, if you took any point in space around the nucleus, the probability of finding the electron. So actually in any volume of space around the nucleus, it would tell you the probability of finding the electron within that volume. And so if you were to just take a bunch of snapshots of electrons, let's say in the 1s orbital, and that's what the 1s orbital looks like. It's just a little, you can barely see it there, but it's a sphere around the nucleus, and that's the lowest energy state that an electron can be in. If you were to just take a number of snapshots of electrons, let's say you were to take a number of snapshots of helium, which has 2 electrons, both of them are in the 1s orbital, it would look like this. If you took one snapshot, maybe it'll be there. The next snapshot, maybe the electron is there. Then the electron's there. Then the electron is there. Then it's there. And if you kept doing the snapshots, you would have a bunch of them really close, and then it gets a little bit sparser as you get out, as you get further and further out away from the electron. But you see, you're much more likely to find the electron close to the center of the atom than further out. Although you might have had an observation where the electron's sitting all the way out there or sitting over here. So it really could have been anywhere, but